Yes. Hello, Sanu.
Yes.
Oh, yeah, okay. Introduce yourself.
Okay. Oh, so hello. So my name is Parthakuran, and I did my graduation from Calcutta University and post graduation from IIT Guwahati. And after that, I started briefly teaching and preparing also for the exam. And my hobbies were in playing table tennis, and I have interest in electronics project. So so this is briefly about me.
Okay. So, you play tennis. So, can you tell me what is the weight of the tennis ball?
I play table tennis,
Yes.
so it's around 40 gram. So
Okay. And what is the standard size of the table?
standard size of the table. Okay, I have to check it. I forget now.
Okay, no issue. So, you have done your masters from IIT Guwahati, yes?
Yes.
Okay. So, how IIT Guwahati is contributing in this geophysics field? Can you tell me any achievement of the IIT Guwahati?
So IIT Guwahati has is in recently they are started about the geo art science one subject, and currently I don't know about it any major contribution, but as they are started about the exploring the earth and seismic, I think in coming year they will contribute.
सानू कैन यू प्लीज यूज लिटिल बिट पास थोड़ा होके बोलो क्योंकि आवाज थोड़ा कम सी लग रही है थोड़ा स्लो स्लो वॉइस आ रहा है
Now I am audible.
नहीं नहीं ऑडिबल तो हो थोड़ा स्लो वॉइस है थोड़ा डाउन है
Okay, voice down है.
ओके कैन यू टेल मी हाउ मेनी टाइप ऑफ जियो okay first tell me what are the geophysical methods
What are the geophysical method? So
yes
geophysical method, it's include that the gravity method, it's seismic method, electrical method, electromagnetic method.
so you are a physics student right
Yes.
physics background okay so
Yes.
why have you choose why have you leave that physics branch you have the options for PhD and you are coming coming to the geophysics why which things attract you here
Actually, geophysics, it's an application of physics. So by geophysics, we are applying the all the physics law, whatever we are theoretically studying. And geophysics, this job gave us the opportunity to experiment Earth. So to know better on the whatever the subsurface or inside the earth. So by the using the physics method, you can. So that's interest me, and there was also lots of field work, and it's gave opportunity to explore all the places in India.
okay what is the difference between the geophysical and geotechnical methods
Geophysical and geotechnical.
yes
Sorry, I don't know about it.
okay so what are the advantage of geophysical method can you name
So geophysical method like that there is a some active method, some passive method. So like gravity, it is the passive method, and the electromagnetic induction or electrical, it is the active method. And advantage is here that without going deeper into the inside the earth, we can explore the what inside the earth, and so that is the great advantage of this method.
Okay, so you are saying without going deeper into the earth, we have the information about the earth. So
Yes,
can we rely on these information or not? Or these have some
yes, we
technical
can.
problem?
So there is problem, there is limitation on this survey, but when we are confirming it through the different method, so that's time we can rely on our data.
Okay. Okay. Comes to the electromagnetic method. So how many type of electromagnetic method do you know?
So electromagnetic method, there is a one is one is triangle method, and another is the phase. We are measuring the phase method, phase and amplitude, and another is the time domain method, TDEM, time domain electromagnetic method. Also GPR, also ground point decelerator.
Okay. Okay. What is the difference between GPR and radar?
So GPR, it is using the high frequency electromagnetic wave, and I think radar is using the radiomagnetic wave. I don't know about surely.
Have you heard about the okay? You don't know the about radar.
Radar.
Okay, what is the full form of this the radar?
So radar is it's used radio signal. Whatever I know.
Okay, yeah, sure. So okay, what is the basic principle that we are using in electromagnetic method?
So electromagnetic method, we are using that one source. So where the electromagnetic is wave is generated. So and the electromagnetic wave whatever generated, that is travel through the earth, and if there is any conducting body, so that will generate eddy current, and that eddy current we are receiving on the receiver coil.
Okay, so you have used the term eddy currents. So what are
Yes.
the eddy currents?
So eddy current is generated when we are changing the magnetic field. So magnetic field by the Faraday's law, magnetic field. So time varying magnetic field, it's produce electric field.
Okay, so can you relate this time, this eddy currents to any Maxwell equation?
Yes, Maxwell third equation.
What is the
So
third equation?
it is the curl of E equal to del by del T minus del by del T. So change in magnetic field will induce the electric field.
Okay, so okay, what is the significance of this equation?
Significance of this in Maxwell third equation
Yes, third equation.
is that we are producing the electrical current by changing the magnetic field. It's also work. It's
Okay,
work
so just tell
similar.
me
We are
what is
generating the electricity. So dynamo is working on that principle.
okay. What the does the curl imply? The curl of any vector quantity. What does it imply?
So so curl implies that it is not a straight line. It is a some rotation is there. So it is not card free. I'm not exactly no exactly tell you the definition right now.
Okay, okay, okay. Tell me the all four Maxwell equation and real physical significance one by one.
Okay, fast Maxwell equation, it is the Gauss law. So Gauss law, it is the if there is a charge, so charge will generate the electromagnetic electric field. So that is the divergence of E equal to rho by epsilon naught, and so it is means that the charge, so electric field generated by the charge. And second law is the magnetic, and there is no if magnet does not exist any monopole. So that is why the divergence of E equal to zero. And third equation is the Faraday's law. So that is the modification of Faraday's law, that is the curl of B equal to minus del V del T. And fourth law is the modification of Ampere law, where we are adding the displacement current and the continuous current.
Okay, okay. Suppose we have there is imaginary. Suppose monopole, magnetic monopole exists. So which
Yes.
Maxwell equation you will modify?
So divergence of B, that will not equal to zero. So that Maxwell equation will be modified.
So only this Maxwell equation will modify or any other also?
So currently only this only modified.
Okay, okay, okay. So have you heard about the telluric currents?
Yes, telluric current is.
What is that?
So telluric current, it is the earth current. So because of the several activities like the ionosphering, the magnetic field changing, and solar radiation, so solar flare, and all this activity will generate electric current in earth. So that current is flowing. So that is known as the that natural current is flowing. So that is known as the telluric current.
So how we are using it in the empty method?
So empty method, we are measuring the telluric current. So by measuring the magnetic uh, component and the electric component, and from that, if we are knowing that the signal frequency, so and we can predict the depth of penetration, also conductivity of the medium.
Okay. So okay, suppose you have the electromagnetic radiation and conductor.
Yes, yes.
Okay. So can you tell me the skin depth for a perfect conductor? Its value.
Perfect conductor skin depth should be zero,
Okay. So what is the meaning of this?
because that there is no penetration of the electromagnetic wave inside the perfect conductor. So actually, the conductivity of a perfect conductor is infinity. If we are so and raised to the zero, so that's why the skin depth will be zero by the formula.
Okay. My last question. So tell me two application of the GPR method.
So ground penetration radar. So we by investigation, ground penetration radar its resolution is very high. So it's high frequency, and it's so subsurface exploration. Also, we are using it in several construction project also. And second thing that second application is so mineral exploration. Also, GPR has a great role.
Okay. Thank you, Sonu.
Okay, thank you.
Okay, Pavan.
Okay. So, Sanu, tell me
Yes.
what is the limitation of electromagnetic survey?
So limitation, one thing that there is the uniqueness problem is all the physical method, and second is the electromagnetic. We are measuring the electromagnetic wave by the means airborne survey. So there, in that case, so there is a depth of penetration is very low.
Okay, okay. So, in electromagnetic survey, we use electromagnetic wave, right?
Yes.
How to generate electromagnetic wave? Do you know?
How we are generating electromagnetic wave?
Yes, yes.
So electromagnetic wave, it is it's generated by the okay, wait, 1 minute. So it is generated by the antenna, some using antenna. So and it is the so two side it is the changing the alternating current, and it will produce the electromagnetic wave.
Okay. So, tell me how to proceed field survey by electromagnetic survey in electromagnetic method. First, we will
So
use first. Yes, huh, tell me.
in field survey we are mainly using uh, the tilt angle method and the time domain. So mostly used currently in the time domain method, time domain electromagnetic method. So by here that we are using a signal, a source generator, and another is the receiver. So source generator will be generate the electromagnetic wave, and that electromagnetic wave will going through the ground. And if there is any subsurface in any conductor body, so there will be interaction with the conductor body, and that's will we receive some signal. So this is the procedure of the electromagnetic survey.
Okay. So you can say that due to primary electromagnetic wave and in conductor influence,
Secondary, yes, secondary electromagnetic
oh,
wave is generated.
so there is current also generated in conductor. Do you know any current also?
ED current generated in conductor.
ED current. Okay. So tell me what is the direction of ED current in respect to the primary electromagnetic wave?
So ED current is it is generated. It is always opposing the original magnetic field. So it's if the magnetic field direction is directly downward, and so eddy current will be opposing so by the Ampere's law, so eddy current flowing like a clockwise, so that it can counter that.
Okay. Okay.
So it's always try to oppose the primary field.
So oppose. So we can say that here some Lenz law apply. We can say.
Length law apply. Yes, yes.
Okay. So what is the Lenz law?
So Length law tell about that the changing the current generated in a such a way that it will oppose the change in magnetic field. So magnetic field always they will always try to reduce it.
Okay.
So
So
that's why in the Faraday's equation the negative sign is came. So curl of E equal to minus del B del T. So negative is came from the Lenz's law.
do you know any relation between the electromagnetic force and change in flux at that time?
Electromagnetic force.
Electromagnetic EMF and change in flux with the time. Any relation between both the quantity?
So that is the Faraday's law of change in flux.
So the EMF is a potential or anything is that
EMF is potential.
potential?
That is the
Okay.
potential, but it is the alternating potential.
Alternative potential. What is the difference between the alternative potential and simple potential?
Means alternating potential it is means that its polarity is changing. It's not a fixed polarity.
Okay. Right. Okay. So Sanu, tell me how to proceed in field survey by the magnetotelluric sounding. How to measure
So in
resistivity
mag-
and yeah.
so in magnetotelluric sounding, we are measuring the electric field component as well as we are measuring the magnetic field component. So we are measuring two electric field component by the inserting that the northeast and the north south and the east west direction to electrode, and we are measuring the by means we are measuring the three magnetic field component by arranging the three coil in orthogonal direction.
Measuring the two magnetic component of or three magnetic component.
I think three magnetic component and two electric field component.
Okay. And what is the depth of penetration approximately, if you know?
So magnetic telluric it is very high. So it's almost we got signal from the mental
Any yeah.
any range you are asking.
Yes, approximately, if you know.
So it's approximately more than 500 kilometers.
Okay, okay, okay. Thank you, Sanu.
Okay, thank you.
Arpita,
Sanu, tell me which physical property we obtain in an electromagnetic survey?
So, ma'am, in electromagnetic survey, we are measuring the conductivity.
Okay. Do you know what are electromagnetic waves?
Yes. So, electromagnetic wave, it is the transverse wave. So, here the electric field and magnetic field. So, perpendicular both the direction of the propagation of the wave. And so, by the changing the electric field and magnetic field, so this EM wave is it's
Okay. Tell me any two or three properties of electromagnetic waves.
okay. One property is it is the transverse wave,
Okay.
and it obeys the Maxwell equation. And
Okay.
so in dielectric medium, if there is conductor, there will be means in a dielectric medium there will be no difference in the
You use a term dielectric medium. What is it?
so dielectric medium it is the so it is the actually it is measuring the difference between the free space and the any material substance is there, so which can produce the electrical polarization effect. So dielectric
Any
measuring by the
material?
dielectric constants. So what?
नहीं नहीं आप बोलो बोलो.
So dielectric medium it is the it's work like a means where the electric field can be propagate without loss. EM wave can propagate.
So you want to say that due to dielectric medium, there won't be any loss in the medium.
Yes.
मतलब इलेक्ट्रोमैग्नेटिक वेव जो जनरेट होगी उसमें कोई एटेन्यूएशन नहीं होगा, राइट?
नहीं नहीं नहीं.
तो ये तो आइडियल केस नहीं हो जाएगा?
हाँ, but ideal case ना. If there is a conductor, there will be attenuation loss. But otherwise, if we consider the perfectly dielectric, there will be no loss.
कि अगर एटीन्यूएशन होगा तो किस किस फैक्टर पे डिपेंड करेगा?
Attenuation is depending on that the conductivity term.
Okay.
And ideal EM wave, it will means if we are see
Okay.
that the
Leave
wave
it. Leave.
equation. Okay.
Okay. um, you use a
Means
term
EM
electric
wave.
polarizer.
Okay, ma'am. One minute. One thing is means EM wave do not depend on the distance from the source.
Sorry, can you repeat?
So electromagnetic wave do not depend on the distance from the source.
Okay,
So
okay.
if there is a okay, ma'am.
Okay. You use a term electric polarization. Can you explain it?
Yes. So elect means when in a dielectric medium, when we are sending an electrical signal, electrical field, we kept a dielectric in electric field. So there is a so charge distribution inside a atom. So nucleus and the electron cloud, so they are displaced by a small distance, which is countering the applied external electric field. So that's why they are polarized.
Okay. So any material can be polarized?
Yes, it can be polarized, but it's depending on the
Conductors,
yes.
insulators, or
No. Conductor can be
semiconductors.
polarized. Conductor can be polarized. Conductor because there is no existence of electric field inside the conductor.
So insulators can be polarized.
Insulator mainly polarized. So
Are
best
you
example
sure?
polarization of the water.
Okay. So, but water is a dielectric or insulator?
So insulator is behaving like dielectric now. Means we can't be classified distinctly. This is dielectric. This is insulator.
So you are
So
saying basically that insulators can also be called as dielectrics, right?
yes.
Or is there any difference?
So there is means there is um, so currently whatever I recall right now that the means there is a there is a common portion between the dielectric and the insulator.
I'm
Also
simply
not
asking, is there
not
any difference or no? Yes या no? अगर है तो कोई एक difference जो दोनों के बीच में है?
so for the dielectric property it need to be electrical polarized easily.
Okay.
So that's
Okay.
it's depend on the dielectric property. But insulator it's not that case. Insulator is the how much means it is no it is resisting the current flow.
Okay. Can you tell me Faraday's laws of law of electromagnetic induction?
So Faraday's law of it says that the change in magnetic field produce the electric field. So that is the curl of E equal to minus del by del T.
Okay. Have you heard about electromagnetic spectrum?
Yes.
What is it?
So EM spectrum it is the means we are according to the frequency level we are distributing the electromagnetic wave in different categories. So these all these categories are known in the EM spectrum.
Okay. Can you arrange all the electromagnetic waves in the increasing order of wavelength?
So like the gamma ray, it is the highest frequency. So I'm from the wave I'm arranging it from the decreasing order means from the low frequency to high frequency. So it is first in the radio wave, then the microwave, then the infrared, then the then the visible light, and then is the gamma ray.
Okay, what is the range of visible waves, visible spectra?
So it is lies in the from the 400 4,000 to 8,000 angstrom wavelength, and yes, so 4,000 to I think 7,000 angstrom its wavelength.
Okay, good. What is the principal band electromagnetic method?
So electromagnetic method, it is the so principle, it is the Maxwell equation. So this Maxwell equation. So actually we are means mainly. So if we are arranging the Maxwell equation, so it's we got a wave equation, wave solution, like, and so that wave is known as the electromagnetic wave.
Okay, Sanu, what is the difference between geologist and geophysicist?
So geologists mainly deal with the rock structure. So and but the geophysicists doing that the subsurface studies.
Okay,
So
so
geophysics is the branch of geology, but so all these geophysical methods also come under geology also.
okay, can you define permittivity and permeability?
So permittivity, it is the measuring that constant in electric field. So in a, and the permeability, it is the magnetic constant. So it's means in permittivity we are measuring that means how the electric field will be changed in a medium, for a particular medium. If we have distance and the charge, we are fixing how the electric field will be changed, and here in this case the magnetic field will be changed, how easily one will be magnetized.
Okay, can you tell the principle or the basic working of GPR?
Okay, ma'am. So GPR, in GPR, so ground penetration radar, we are using the high frequency electromagnetic wave. So by the high frequency, we are the so the main. So if we are arranging in the Maxwell equation, so we got the del dot p equal to first term equal to del b del t, and second term will be del 2, means the second derivative of the time. So first term will be cancel out used to high frequency, and the second term will be dominate, and that second term, it's behave like a wave. And so for, okay, you were asking that what is basic principle, na, in
Yeah,
GPR.
just basic working or principle.
Okay. So GPR method, we are using the high frequency electromagnetic wave, which by that we are changing the dielectric. We are measuring the changing of dielectric by the measuring the velocity, and that's the basic principle. So we are measuring actually changing dielectric in GPR method.
Okay, you use it on high frequency.
Yes.
Can you tell me the range?
So it's range in megahertz.
Okay, and up to how much depth we can go in GPR?
So GPR is depth is very low due to its high frequency.
Sorry, can you repeat?
So its depth is very low due to high frequency.
Lower. Okay, order of.
I think it is 20 meters, less than 20 meters. But it depend on
Okay.
the properties also. Means in some case it's going higher if we are measuring GPR in heights or other thing.
Okay, Sanu. Thank you.
Okay, thank you.
Okay, Gauri.
Yes, Sanu. Sanu, what is the basic principle used in this EM methods?
So basic principle is using here that the electromagnetic wave, it will be the time varying magnetic field. That time varying magnetic field in the presence of conductor will generate the ED current, and that ED current will be we are receiving in receiver signal, and by that we are exploring the subsurface.
Okay.
Oh,
Which
1 minute.
Mhm.
Give me one.
What? Hello? Hello? Am I audible?
Yes,
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 yes, you
Gauri.
are audible.
Okay. So, how do we generate this electromagnetic wave that we use in this EM method?
So electromagnetic wave.
Yeah.
In
How do
you
we
are
get?
asking me any experimentally or means any equation.
Experimentally, how we are generating? Hello?
Hello. So experimentally by using I think that antenna, we are generating the electromagnetic wave. So here we are in antenna we are sending the alternating current, and there is in pi by I think there is a difference between the electric current sending and the magnetic pulse. There is some special phase angle. By that the antenna we are generating the electromagnetic wave.
Okay. What are the different parameters we measure in field to analyze this properties of subsurface?
What are the so like
Mm,
the gravity magnetic, EM resistivity? These are
mm,
you are
I mean,
asking.
which all factors are measuring for the analysis purpose? We are plotting, usually used to identify a map to analyze this properties. Now, which all parameters are we used to analyze this?
Like in gravity, we are measuring the density, and the electromagnetic wave, we are measuring the conductivity.
No, no, no.
And
Like that, we are measuring voltage in electric method. What parameters are in field?
in EM, we are measuring the so the means we receiver we are measuring that the whatever the upcoming the EM wave we are generated. So that's we are measuring. So one is the primary field and one is secondary field. We are measuring the secondary field. So by measuring some coil or some.
Okay. What are features of this primary and secondary field we are measuring?
So they are amplitude and phase component.
Okay. Have you heard of dip angle?
Yes, deep angle.
Do you know what it means?
So deep angle actually it is the electromagnetic survey, and here that the we are measuring that the so one here one source is the EM wave is generating, and another is the in presence of the primary field and the secondary field. So the so we are measuring the total field, so it will differ from the original primary field. So at what angle it is differ, so we are measuring that angle. So this is known as the tilt angle and or deep angle.
Okay. Do you know any method which measures this difference? Can
So
you give
this
an
is the we are mainly here a very low frequency and the mag or the frequency magnetic method.
Okay, okay, good. So, can do you know what is the parameter that is defining the um, what we are trying to measure in GPR technique?
What are parameter?
Which subsurface parameter we are trying to?
So we are measuring the dielectric. So changing dielectric constant we are measuring in GPR
Oh,
method.
okay, so what is this dielectric constant? Do you know what does it mean?
Yes, dielectric constant. It is the ratio of the so permittivity of that material by the free space permittivity. So that is the dielectric constant.
Can you repeat it once more? I
So the permittivity of that material by the free space permittivity. The ratio
Okay.
of that will be give the dielectric constant.
So it is equal to this relative permittivity.
Yes, relative permittivity.
Is there any condition uh, at which you can say it's dielectric or it's always?
So dielectric, any condition it is it's called dielectric.
Yeah.
So I have to read about it, but whatever I know that it's how much
o-
it can be polarized or not,
Okay.
means how easily it is electrically polarized.
Can you differentiate between this permeability and permittivity parameter?
Okay, so permittivity it is the electrical constant. So by the changing material, how the electric field is changed due to the permittivity and the permeability, the it is magnetic permeability, it is the magnetic constant. So how can be one material is magnetized? So
Okay. Um, can you arrange this in electromagnetic spectral elements like gamma rays, X-rays, UV, IR in the order of
yes,
increasing
yes,
frequency.
yes. So increasing frequency like that, the radio wave has less frequency. So from the radio wave, then microwave, then the infrared, then the visible, then the gamma ray.
Okay,
So
so
in this order.
okay, okay. Of these ranges you mentioned, which all waves are used in the electromagnetic stuff?
So radio wave are using in the very low frequency range. So PLM method we are mainly using the radio wave and the I think the high frequency range we are using the megahertz using in GPR method
Okay. What's the frequency range we use in GPR?
in megahertz frequency.
Okay, so what about this magnetic telluric method?
So magnetic telluric it is the its phenomena is arising due to the ionosphering changing the electrical density. So which generate the alternating current and the alternating current will produce alternating magnetic field and that will generate the inside the earth that will generate the electric current. So that is the magnetic telluric method.
Okay, okay. What is the frequency range we use in that?
It's I think 1 to 1,000 hertz. So,
Okay. Um, okay, what is the Can you comment on few application of this magnetic fluid method?
Yes, ma'am. Magnetotelluric method we are using it is very deep investigation of the earth. So
Okay.
by the knowing the conductivity, so it's have a very high depth of penetration.
So
And
its
so
application
mainly
in
deep exploration we are using magnetotelluric.
okay, um, in so, that's it. Some okay. Mm.
Okay, thank you.
Okay, Mohit.
Uh, Hello, Sanu.
Yes, sir.
How are you?
Good.
Good, okay. Can you tell me what is geophysics?
What is geophysics? So geophysics, it is the part of the earth science, and by the using the principle of the physics, we are investigating the subsurface of the earth, and so this is the geophysics.
Okay, what physical principles we are using basically?
What physical principle?
Yeah, you are saying that geophysics uses the principle of physics, right?
Okay, yes, yes. So principle
Okay.
of physics like the gravity, we're using gravity. Then we are using the magnetic property, AC properties, and the electromagnetic.
Yeah, like in gravity, what basic physical principle we use?
So in gravity, we are measuring that the means by the Newton's law. So there is a gravity depend on the density. So in density variation. So by gravity method, we are measuring the density variation,
Okay,
and
by
the electrical
gravity.
method
हाँ, yeah, बोलिए.
and electrical method we are measuring the conductivity and resistivity. Electrical
Using which
EM method.
principle?
So by the Ohm's law and for the electrical method, and but in electromagnetic method we are using the Maxwell equation.
In the Maxwell's equation. And in seismology, which physical principle we
And
are using?
seismology we are using the acoustic principle. So acoustic and ray also ray optics or principle also we are using.
Okay, Snell's law and law of
Snell's
reflection
law.
and reflection, right?
Yes.
Okay. And what are the basic methods in geophysics we use?
Basic method all these the gravity method. These method
Okay,
these
gravity.
are
Okay,
gravity electric. Yeah, these are the basic method of the investigation of the Earth.
okay. Can you tell me what is the job profile of a geophysicist in the GSI? What a geophysicist do basically in the GSI?
Okay. So what I don't know exactly, but whatever I heard about it, that in a geophysics as a geophysicist, there is a role in a field survey, and also that in field survey they are acquiring the data. It's the magnetic, electrical resistivity, all these things, and it will be in they are processing all this data and they interpret it, and these data and the interpretation and that interpretation came out the whatever the mineral composition or another thing. So these are the main work.
Okay. So can only geophysicists do these things, or we need along with the geophysicist
No, no,
some
we
geologists or some
there is
geochemists?
there is yes, yes. They all three are important here.
Okay.
So all they
So
have different role. So geology is study of the earth, means rock structure, and geochemistry is analyzing the all the material in presence. And they all GSI is combining all the data and
Okay, so basically in GSI, you have to do collaborative work with the geochemist, with the geologist, right?
Yes, yes, yes.
So, do you have these collaborative capacities to work in a group?
Yes, sir. I think I have the collaborative capacity.
So, can you give an example when you have used these collaborative skills and you have done something in the group?
So in games, I sometimes I lead. So in playing, so I can arrange. Also, some
Can you
blood
repeat?
donation camp.
Can you repeat what you said?
So in sports, so like
Okay.
cricket, I did few time I did captaincy, and
Okay.
and another thing that I in college time I organized on blood donation camp. So not only I also some other friends. So we are mutually arranged it.
Okay, good. And Sanu, what are your hobbies basically?
So my hobbies are the I my interest in electronics instrument and the electronics project. So I often do it and modifying the electrical product. And another thing, the playing table tennis. These are the my hobby.
Okay, so you are interested in electronics project, electronics product basically, instruments.
Yes, yes, yes. I love the UI project. So whatever they're modifying, not large scale, but in a small scale, right?
Okay, so tell me, as a geophysicist, when you go on the field, what are the
Yes.
electronic instruments that you have to carry with yourself?
So it's depend on the survey. If we are measuring the, if we are doing the electrical survey, so we are carrying the instrument, measuring the voltage, measuring the current, and if we are doing the EM survey, then we are doing the receiver coil, transmitter coil.
Oh, okay. In case of well logging,
So coil logging, I don't know much about it, but
okay, no problem. So, which method do you like the most as a geophysicist when you do have to do field work?
which method I like most.
Yeah,
So I think I like the electrical method most.
electrical method most.
Electrical and EM method.
Electrical and EM method. And what methods basically GSI uses, or what are the basic methods on which the GSI work?
So GSI mainly work in gravity magnetic and EM
On EM method also.
for a,
Okay.
for a geophysics.
Okay. So in electromagnetical method, we use the electromagnetic wave, right?
Yes,
And in remote sensing, we also use the electromagnetic wave.
yes, remote sensing also electromagnetic work.
Have you read the remote sensing?
Yes, I have read.
So in that we use the electromagnetic wave, right?
Yes, electromagnetic work. We are read.
So what is the basic difference between these two methods?
So in both cases, we are using the electromagnetic wave, but the in remote sensing, we are acquiring the data far distance. But in electromagnetic case, there is a we can do it at a distance, by we can do it in the ground also.
Okay, good. And what is the basic principle we use in the electromagnetic method?
So in electromagnetic method, as the change in magnetic field, so we are using the Faraday's law and also other Maxwell equation also. So it is the change in a electromagnetic spectrum, electromagnetic wave. So magnetic field is continuously changing, and that continuous change will be in a conductor ED current, and that current the influence the primary signal. So we are measuring the outcome of the signal, and from that we can predict the all the data and the conductivity of the material.
Okay. And what is the Faraday's law?
Okay, Faraday's law tell about that the change in magnetic field produce electric field.
Okay, you are saying that changing magnetic field will produce
So
electrical
it is
field, right?
the card of E equal to means change in magnetic field, the magnetic flux also can say.
Okay. Will induce the electrical current, right?
Yes.
Electric field. So how the magnetic field is generated? What are the process by which we can generate magnetic field?
So there is a change in alternating means magnetic field is generated by the continuous movement of the charge, that is the current. So if we are flowing current, that is magnetic field will generated. Also we are changing electric field also, we are generating the magnetic field.
Okay, so there is a special term we use when we talk about changing electric field will generate magnetic field. Do you know the
Yes,
term?
that is it. That is the displacement current.
The displacement current. Very good. What is the displacement current? And what is the formula for that?
So displacement current, it is the means by changing electric field we are generating the magnetic field, and its formula is mu and epsilon. So magnetic permittivity and the electrical both constant into del E by del T.
I'm asking the formula of electric displacement current, ID. Okay, so what will be that?
Electrical displacement current na.
Yes.
So current density, whatever I say that is the current density. If we are multiplying by the area, then we have got the current.
Okay. And who gives the equation displacement current term?
So it is the adding by the Maxwell. So
Okay. And before Maxwell's correction, what was the equation name?
so before Maxwell, it is the Ampere's law. So Ampere's law. So Maxwell is modifying the Ampere's law
Okay, good.
by the
So
adding the
in
displacement current.
okay, so in which electromagnetic method we use the displacement current concept?
In GPR mainly, we are using the ground penetration generator.
Okay. Do you know about the magnitude ratio?
Yes, magnitude ratio.
What is that? And
So
what
it
it
is the
signifies?
ratio of the displacement current by the conduction current,
Okay.
and that ratio will be the proportional to the I think frequency,
Okay. And
and inversely proportional to conductivity.
okay. So as conductivity will increase, magnitude ratio will.
So means this, yes, it is decreasing.
Okay, leave it. Tell me what magnitude ratio signifies. Let's. I mean to say when magnitude ratio is less than 1, when magnitude ratio is 1 or it is greater than 1. So
So I said it that it is depend on the frequency and the conductivity. So if there is a high conducting medium, so in that case it will be very means it is very less than one, and it is the if it is the resistive medium, then it will be means displacement current will be dominating.
okay, so in case of GPR method, magnitude ratio will be less than 1 or greater than 1.
It will be greater than one.
Okay. Why GPR method is most important? Eh,
So GPL method, because it's a high resolution and it's due to high frequency, and we can do it detailed study. So each individual expert we can study from the GPS.
What is resolution?
So resolution, it is the how good we know the structure, how accurately, how precisely.
Okay. And do you know something about horizontal resolution and vertical resolution? And what is the difference between them?
Yes, I can know, but currently I can't recall about it.
Okay, no problem. Okay, thank you, Sanu.
Okay, thank you.
ओके आई थिंक सभी का हो गया है ना आई थिंक
I think Abhinas क्या नया ऐड हो गया?
सो ओके गिव वन बाय वन प्लीज फीडबैक गौरी
Sanu, your answering was quite good. You answered almost every question I
I think
asked.
Arga is left, na? Arga is left. Arga is not. Arga, do you want to ask any question?
No, I have no questions. All the questions have been asked, I think.
Okay, okay, no problem. Okay, Gauri, continue, please.
Okay, your confidence level was also quite good. So your overall performance was good.
Okay.
मोहित
हाँ सानू इंटरव्यू अच्छा था आपका आई थिंक ऑलमोस्ट एवरीथिंग वाज गुड
Okay, any correction in question, whatever ask?
नो आई थिंक ऑल आर गुड एट सम लेवल
अर्पिता
Anu, your interview was very good. आपका कम्युनिकेशन भी अच्छा है, आप आंसरिंग भी अच्छी कर रहे हो, थोड़ा सा बेसिक्स को आप ब्रश अप करें।
Okay.
हाँ, और तो एवरीथिंग इज गुड।
आ गया
हाँ, मैंने जो सुना तो अच्छा ही था, बहुत ही अच्छा था.
Okay, thank you, everyone.
सानू ओवरऑल इंटरेक्शन विद यू वाज वेरी गुड एंड हाँ वही है कि जो अर्पिता ने बोला है कि हाँ बेसिक्स एक बार दोबारा एक बार देख लो आप और हाँ बाकी सब अच्छा ही है आपका
और जो क्या परमिटिविटी और कोई बार बार क्वेश्चन मतलब परमिटिविटी क्या मतलब वही डेफिनेशन है ना और नहीं मैंने गलत कुछ बोला उसमें
Permittivity definition and permeability was correct almost. But that dielectric constant, we are measuring it at constant electric field. We are calling it as when relative permittivity is measured at constant electric field. We are calling it as dielectric constant.
अच्छा
and
जो
dielectric what dielectric we are not measuring in constant electric ना I'm not
Yeah,
getting what
at
please
constant
repeat
electric
Gauri.
we are this relative permittivity is called as dielectric constant.
Okay, means when it is constant electric field.
Yeah.
Okay, sorry, I don't know about it.
अच्छा मेरा एक डाउट है
And
कोई
another thing that what I'm asking all of you means whatever I try to explain, it's means do you understand about it? Whatever means, or it is just you have already basic knowledge. That's why you have got that point. If you are completely fresh, then you can understand what I'm trying to say.
Yes, Anu, what are you saying is reaching to us, reaching to us. अल्टीमेटली जो भी वहां पूछेंगे उन्हें भी तो नॉलेज होगी, तो डेफिनेटली दे विल अंडरस्टैंड.
Okay.
अच्छा, मेरा एक डाउट है
Means
कि यस, हाँ सानू.
मैंने जो क्वेश्चन पूछा, मतलब कीवर्ड मिस नहीं कर दिया, मतलब जो की टर्म है.
हाँ, की टर्म्स जो है, हाँ मिस नहीं करने. आप जो पूछोगे, सपोज उनके मन में आ जाए आपने पोलराइजेशन कहीं यूज किया, तो डेफिनेटली दे विल आस्क द डेफिनेशन व्हाट इज द पोलराइजेशन.
यस यस यस
ठीक
यस.
है. हाँ, कौन से पोलराइजेशन है. इलेक्ट्रिक पोलराइजेशन होता है, ऑप्टिक्स में होता है ना.
हाँ,
ऑप्टिकल
दोनों डिफरेंट
पोलराइजेशन,
पोलराइजेशन.
और आजकल नया नया भी है, पॉलिटिकल पोलराइजेशन भी है.
हाँ.
तो वो हर जगह है कि बस आप की टर्म्स एक्चुअली ये शुड नो द की टर्म्स जब भी आप यूज करो. वैल्यूज पता होने की, लाइक डाइलेक्ट्रिक कांस्टेंट है, सो यू शुड नो फॉर द एयर वाटर.
यस यस.
अच्छा, मेरा एक डाउट है कि जो परमिटिविटी ऑफ फ्री स्पेस है. हेलो.
हाँ. यस.
हाँ. सो क्या वो नॉन जीरो वैल्यू है ना. सो क्या फ्री स्पेस इलेक्ट्रिक फील्ड स्टोर कर सकता है. फिर इसका मतलब तो यही हुआ.
प्लीज रिपीट अगेन. परमिटिविटी ऑफ फ्री स्पेस
मीन्स परमिटिविटी का जो मतलब होता है, इट इज द एबिलिटी ऑफ मटेरियल द स्टोर द इलेक्ट्रिकल एनर्जी, है ना.
यस यस.
तो फिर अगर फ्री स्पेस की नॉन जीरो वैल्यू है, तो मीन्स फ्री स्पेस इलेक्ट्रिक एनर्जी स्टोर कर सकता है. तो मुझे थोड़ा कंफ्यूजन हो रहा है, क्या मतलब है
हाँ,
इसका फ्री स्पेस की.
स्टोर तक.
एनीवन. मोहित, अर्पिता, पवन, गौरी, आज्ञा.
अर्शदीप, क्या रिपीट करोगे एक बार क्वेश्चन?
एक्चुअली परमिटिविटी जो है, इट इज द एबिलिटी ऑफ ए मटेरियल टू स्टोर द इलेक्ट्रिकल एनर्जी, है ना.
हाँ
सो फ्री स्पेस के लिए हमारे पास जो वैल्यू होती है 8.85 10⁻⁻12 फैराड पर मीटर, वो नॉन जीरो वैल्यू है. स्मॉल है बट स्टिल नॉन जीरो, है ना.
जी.
तो इसका मतलब फ्री स्पेस कैन स्टोर द इलेक्ट्रिकल एनर्जी और वैक्यूम.
I think the electric permittivity is the ability of a material to permit the electrical field. How much the electric field lines can pass through the material. Okay. Or you can say how much is the ability to polarize a material. Okay. So exact answer तो नहीं पता इसका भी.
हाँ, मतलब परमिट
बट
जितनी है
स्टोर कर सकते
पूरी
हो. मतलब जो
जी.
फॉर्मूला देखोगे ना, जो इलेक्ट्रिक एनर्जी स्टोर, जो हाफ एप्सिलॉन इनटू दैट ई स्क्वायर, फ्रॉम दैट फॉर्मूला यू कैन से दैट द एनर्जी स्टोर कर सकते हैं फ्री स्पेस भी.
हाँ,
मीन्स
एनर्जी स्टोर कर
अगर
सकते
हम
हैं.
परमिट कर रहे हैं तो मीन्स स्टोरी हो रही है वो एक तरीके से, है ना.
हाँ, स्टोर ही हो रही है.
सिर्फ इसीलिए डिफाइन किया है कि ताकि हम रिलेटिवली निकाल सकें और सबसेंट मटेरियल्स की एज ए रेफरेंस, जस्ट
हाँ, ये भी हो सकता है.
कि जस्ट रेफरेंस वैल्यू ले ली है हमने एक, और इसके रिस्पेक्ट में हम सारे डायरेक्टली क्वेश्चन वगैरह चेक करते हैं बस.
हाँ, हो
हाँ,
सकता है.
एक्चुअली तो फ्री स्पेस मतलब कुछ है नहीं है, मतलब इट्स ए मैथमेटिकल टर्म.
क्यों, तो वैक्यूम और फ्री स्पेस, वैक्यूम तो होता है ना, पर
बट परफेक्ट वैक्यूम कुछ नहीं होता ना. There is always atom, some atom will be always there or something. It's not perfectly vacuum. Means whatever I know about it, but I don't know much.
अच्छा, एक 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 और क्वेश्चन है मेरा कि जो इंसुलेट डाइलेक्ट्रिक है, तो डाइलेक्ट्रिक और इंसुलेटर में डिफरेंस क्या होता है, मेन डिफरेंस?
जिसने और पिता ने पूछा था ना।
हाँ हाँ हाँ, अर्पिता, वुड यू लाइक टू आंसर दिस?
यार मेरे को ना खुद कंफ्यूजन है, बट मेरे अकॉर्डिंग कुछ इंसुलेटर्स तो ऐसे होते हैं जिन्हें हम डाइलेक्ट्रिक बोल सकते हैं, मतलब वही जो सामने बोला था कि जो पोलराइज किए जा सकते हैं। तो उसमें एक एग्जांपल आपका जैसे वाटर भी हो गया, डिस्टिल वाटर स्पेशली, है ना, और वैक्यूम भी हम कह सकते हैं, बट वो कैसे ये नहीं पता, ये मेरे को इंटरनेट पर ही मिला है। तो वो ही वो इंसुलेटर्स जो इलेक्ट्रिकल एनर्जी को स्टोर कर सकें, दैट कैन बी कॉल्ड एज डाइलेक्ट्रिक मटेरियल्स।
ओके, मींस ऑल इंसुलेटर्स आर नॉट डाइलेक्ट्रिक, है ना?
यस यस, इंसुलेटर्स में तो हमारे वुड वगैरह भी आ गए जो बिल्कुल ही इलेक्ट्रिसिटी कंडक्ट नहीं कर सकते। आई एम
हाँ,
नॉट।
लेकिन पोलराइजेशन तो सभी इंसुलेटर में होता है शायद।
नहीं, वुड है अगर तो उसको हम कैसे पोलराइज करेंगे?
या फॉर
बट
एग्जांपल डायमंड।
वुड में भी ऑल्टरनेटिंग करंट पेनिट्रेट करता है ना, मतलब
नहीं,
इट्स आल्सो
डायमंड
डिस्प्लेसमेंट
डायमंड
करंट।
डायमंड को कर सकते हैं हम। इट इज अ परफेक्ट इंसुलेटर एक तरीके से।
अच्छा, जो जो डिस्प्लेसमेंट, जो इलेक्ट्रिकल मेथड में जो डिस्प्लेसमेंट करंट का टर्म जो थ्री करंट टर्म था ना, कंडक्शन, डिस्प्लेसमेंट एंड इलेक्ट्रोलाइटिंग। So displacement, this is the insulator na, that current is conduction is the insulator na. So insulator can be also, they can current can travel in insulator also.
कोई भी प्लास्टिक मटेरियल है उसको तो हम पोलराइज नहीं कर सकते अगर, तो वो तो इंसुलेटर है।
नहीं सानू, हर एक सारे नहीं हो सकते इंसुलेटर पोलराइज्ड। अगर ऐसा होगा तो कटआउट्स आपने देखे होंगे घरों में लगे होते हैं, सिरेमिक के
हाँ,
बने
but
हुए।
small
अगर
amount
वो
of it's depend on, it's actually the conductivity is depend on the frequency. If there is, we are using the high frequency signal na, that's for that earth is also conducting. So it's depend on completely based on the frequency. So that time the displacement current will be dominating. And displacement current, air can be also, it's work as a conductor also. It's if the frequency is very high.
जो हाई वोल्टेज लाइंस होती हैं हम उनके लिए जनरली इंसुलेटर वायर्स यूज करते हैं, वो इसीलिए ही तो करते हैं ताकि अगर उन पर भी अगर वो भी अगर पोलराइज हो गए तो उनके टच होते ही किसी को भी करंट लग जाएगा।
नहीं, पोलराइज होना और चार्ज कंडक्ट करना दोनों तो अलग थिंग है ना।
हाँ,
पोलराइज
different thing.
पोलराइज कैसे होता है? एक इलेक्ट्रिक फील्ड आपने दिया और जो न्यूक्लियस तो सभी में होता है, न्यूक्लियस और एटॉम्स। तो एटॉम जो इलेक्ट्रॉन होता है वो इलेक्ट्रिक फील्ड के ओर चला और जो न्यूक्लियस होता है वो अपोजिट दिग में चला। तो थोड़ा सा चार्ज सेंटर का डिफरेंस तो रहेगा। डाइलेक्ट्रिक कैन बी पोलराइज्ड मोर एफिशिएंटली, बट इंसुलेटर can be polarized, but I all insulators can be polarized, but I think in small amounts. Those are perfect insulators.
और ये भी है, मतलब करंट कंडक्शन, अगर चार्ज का डिस्प्लेसमेंट नहीं होगा ना तो करंट कंडक्शन का कोई मतलब ये नहीं है। इन डाइलेक्ट्रिक करंट देयर इज नो डिस्प्लेसमेंट इन चार्ज, सो जस्ट देयर changing in distance, changing in
बट
position.
आज्ञा, यू आर सेइंग कि हाँ सम एक्सटेंट तक हो सकते हैं, बट अगर सारे ही इंसुलेटर होने लग गए तो एसी फील्ड में तो फिर वे भी डिस्प्लेसमेंट करंट शो करेंगे और करंट आएगा।
हाँ, करंट जनरेट होते हैं ना, बिल्कुल फ्री नहीं होते ना, इसलिए फ्रीक्वेंसी लो रखा जाता है।
ओके, इट इज अ वेरी कंफ्यूजिंग टॉपिक।
एक्चुअली जब ऑल्टरनेटिंग करंट देते हैं इंसुलेटर में तो फिजिकली करंट फ्लो तो नहीं होता, वो पोलराइजेशन चेंज होता है। एक बार पॉजिटिव पोलराइजेशन फिर नेगेटिव पोलराइजेशन उसको हम कुछ
हाँ, एंड दैट इज
मतलब
द
सोच,
डिस्प्लेसमेंट करंट।
हाँ, तो डिस्प्लेसमेंट करंट तो सभी में होता है शायद, कंडक्शन करंट नहीं होता, लेकिन बट डिस्प्लेसमेंट करंट तो सब इंसुलेटर में भी हो सकता है, आई थिंक। आई डोंट नो एक्चुअली, बट
अगर एक्चुअल में होगा, सब में ही होगा डिस्प्लेसमेंट करंट, तो फिर तो आपने देखा होगा हाई टेंशन वाले रेलवे लाइंस पे भी लगे होते हैं,
बट इसका
तो वो भी
डिस्प्लेसमेंट
एक्सप्लोजन
लग
बहुत
करंट,
कम
जाएंगे।
होता है ना।
डिस्प्लेसमेंट करंट तो कंडक्शन करंट के बिल्कुल बराबर है ही नहीं, वो तो, हाँ,
इट्स वेरी लेस। और एक बात है ना, डिस्प्लेसमेंट करंट में जो टर्म है ना, जो डेली बाय डेल्टी मींस इट्स डिपेंड ऑन फ्रीक्वेंसी आल्सो। सो तो चेंज इन इलेक्ट्रिक फील्ड में उसमें फ्रीक्वेंसी भी टर्म आएगा। So you all we have to check it. Next day we can discuss about it.
ओके, सो एंड करें सेशन फिर।
Okay, next day कब होगा, मतलब next session?
टुमारो।
Okay, we are ready for tomorrow.
यस।
पवन, आप रिकॉर्डिंग स्टॉप कर सकते हो।
अच्छा अच्छा।
टॉपिक क्या रहेगा?
टॉपिक यही रखेंगे अभी, इंटरव्यू इस पे ही, ए मेथड पर ही।
ओके।
और सर आप रिकॉर्डिंग मतलब ऑफ कर दो, मेरे पास अभी फोन में यूज कर रहा हूँ ना।
पवन, मैं भी फोन से ही कर रहा हूँ अभी तो।
अर्पिता, मैं सभी को मैं कोर्स बना दिया, सानू जो भी है।
मैं
लैपटॉप
भी फोन।
ठीक है, तो सेशन